Hi, my name is Chandra, and this video is for the regression modeling in data science. So I hope you all are doing well, and see what is regression modeling in data science. So we have two agenda here: demonstration of estimation model evaluation and stepwise regression. So what is estimation model evaluation? It's crucial to access performance of regression model. Basically, this suggests the task of evaluating the performance of a regression model. This typically involves using various matrices to access okay to access how well the model fits the data and how accurately it can predict new data point. Okay, so common model evaluation technique could be mean squared error. We have a root mean square error, mean absolute error, r squared, and adjusted r squared. Okay, so let's see the demonstration of stepwise regression. So stepwise regression is a statistical method used to select the best subset of independent uh, variables to include in a regression model. It involves adding or removing variables in a step-by-step process, uh, aiming to maximize the model predictive power while minimizing the risk of overfitting. Okay, so we have a types of stepwise regression. The first type is forward selection, that starts with an empty model, and at each step the variable that adds the most explanatory power to the model is added. And the second can be backward elimination, start with a full model containing all potential independent variables, and at each step the variable that contributes the least to the model is removed. Okay, so this is about stabilization. So let's look at some practical example here. So we have again same thing. We have a test split, we have a linear regression, we have a matrix that will calculate the absolute error, mean squared error, and R2 score. Okay, so we are doing nothing, we are just creating a sample data set in this NP seed. Okay, and after that we are training this test split, and we are creating a linear regression model and fitting it in the model. Then we are predicting the y value for the x test, and so here we are getting the mean absolute error, mean squared error, and p squared MSE. So absolute error or squared error we can consider as how far the actual value and the predicted value is from how distant it is. So let's run this. After running, we have a absolute error of 1.18, mean squared error, and RMSE, root mean squared error, that is of course the distant square between the actual value and predicted value through the linear regression. Basically linear regression uses something like Excel draw. So in this, suppose we have a line here. Is this? Okay, no matter in this little bit. Suppose we have a point here, here. So okay, so linear regression does only get the line that is nearest to the point of all that, and this is the distance between this is the predicted value that will be predicted by this is the predicted value we have here. So here we have a predicted value. This predicted value. This is the actual value we have. So the actual value is so this distance is being squared. Okay, so this is the funda, the simple thing. Okay, so this is the stepwise regression that I have tell you, and thank you for watching this video. see you next time.